William Shockley, John Bardeen, Walter Brattain. And they were doing what if we did these devices and junctioned them like this? Wouldn't it be a semiconductor, and couldn't it be used for amplification? Where the transistor was invented. And they all got the Nobel Prize for co-inventing the transistor. This is a picture of a transistor. It's a semiconductor device that's used to amplify. You remember that triode tube that I showed you earlier? Pull a tube out, stick a transistor in, change your voltages, same principle. Used for amplification. This is a high power transistor, medium power transistor, and then it gets smaller. This is the way transistors are made. An N-type material, P-type material, N-type material. We have two types of transistors, NPN, PNP. And when we look at our drawings of transistors, you notice this is an NPN transistor. See the arrow? This is a PNP. NPN, negative, positive, negative. PNP, positive, negative, positive. How do I remember that? Looking on my schematic diagram. That's a not pointing in transistor. This is a pointing in transistor. If you remember that, if it's not pointing in, it's an NPN. If it's pointing in, it's a PNP. Isn't that fascinating? Here is a transistor amplifier. We've got our signal coming in. We've got a bias. The signal is going to the base of the transistor. Current flows up through the emitter, through the collector, through this resistor. DC is decoupled, and the speaker is driven. One battery supplies the whole thing. I want to have to expand on that on the web page because I'm flying through this. Here's a common emitter amplifier. We've got an input signal that could be an audio wave that would be coming from a preamplifier. It is dropped across this resistor. This is a variable resistor, and it's a volume control. And depending on where this wiper arm is tapping on this resistor, the signal level is fed through to this capacitor. If the tap is up here at the top, then you're getting all of the signal, so it's got a loud volume. If you put the tap down here at the bottom, or the wiper arm down here at the bottom, it's at ground, you're going to have no volume at all. And so we have a linear volume control that can give us a signal from maximum to minimum depending on where we place this wiper arm on this potentiometer here. The capacitor is here to decouple DC but pass AC, so we still have our signal here, and we're feeding it to the base of this transistor. This is an NPN transistor, and sometimes we put a little capacitor here on this biasing resistor at the bottom of the emitter to allow the signal to work better and amplify better. And so when we apply our signal to the base of this transistor, then that will control. And also, let's go talk about biasing the base of the transistor. We're going to put a resistor here and connect that to the positive voltage. We're going to put a resistor here and connect that to ground. Now, depending on the values of these two resistors here and here, I can make it any voltage at this point from whatever the positive supply voltage is to ground. And so I pick the right bias point to allow this transistor to be in the middle of its conduction point. And so once it's sort of operating with just barely, we want to have it where it'll be able to swing both low and high in its current flow from the emitter through the base to the collector, depending on this signal. So once it's biased where it's turned on, then this signal comes in through this capacitor, is fed into the base, and that controls the flow of current from ground through here, through there, and back up to the positive supply. That then would amplify this signal a great deal, and then it feeds through this capacitor and then through to this loudspeaker to make sound in this case. So this is the way the amplifier is working. A little bitty signal at this point is controlling and making a great big signal at this point. I could also put a dropping resistor here to, bias my transistor further and allow the signal to be fed to the speaker better.